Maybe we'll just put a happy little seedling over here. Hey everybody, it's Josh Painter back with episode 3 of Happy Seedling. What is the Happy Seedling? Well, it's just a simple introductory set of videos for aspiring Chia developers like myself, who found the initial documentation and tutorials challenging and like maybe even a simpler explanation. So we're here to start from the very basics and answer some questions. Be sure to check out episode 1 and 2 for some background, and that will help you with this episode for sure. So what are we going to be talking about today? Coins, puzzles, and solutions. Oh my. You probably heard these terms thrown around in a lot of the Chia discussions in the community, and even if you've looked in some of the tutorials and some of the code itself. But what are these things? What actually are they? As a developer, we like to actually know what we're dealing with. So what is the kind of the concrete idea behind some of these terms? Let's dig in. First, though, we need to talk about some other terms, some basic concepts, just to make sure that we're all on the same page. So you probably heard the idea of a hash. What is a hash? Well, if you imagine a document, any sort of document that's got a lot of text, it could also be an image or any sort of document with lots and lots of text in it, you're able to pass that through a hashing algorithm and turn it into a simpler form of that text. Now, of course, there's no way to get back the original document from such a simple form, but we know that if we pass this document through the exact same hashing algorithm, we will always end up with these characters. And that's interesting and unique. It's very cool property that we use in lots of different ways. If we simply changed a single character over here, just a single letter in this document, then this hash would be completely different. Like it wouldn't just be one letter that would change. It would be a completely different looking hash. So in this way, you can be sure that the hash at least represents the original document, even though you can't get back to the original document just from the hash. And we actually take that, we use that as our advantage later, you'll see. Moving on. Puzzles. So in the Chia world, you've probably heard the term puzzle. What is a puzzle? Well, other than a great mnemonic device that you will learn to, I think, appreciate as you do learn more, for now, just think of it as code. So if this is your coding window that you normally like, your IDE, then a puzzle is just simply a bit of code that has locked up a coin. Think of it that way for now. It's much simpler to think about. So then what is a puzzle hash? Well, a puzzle hash, of course, would then be that puzzle code hashed into a much simpler representation. So again, we cannot get back to the original puzzle code from just the hash, which is important. But if you do have the original puzzle code, you can hash it again and verify that that is the correct hash that you originally stored in the first place. So, just to recap, a hash is a simple representation of a much bigger document. A puzzle is just simply code in Chia terms that runs on the blockchain for the coin spins. So a puzzle hash then is simply a hash of that puzzle code that we just talked about. Okay, so now let's talk about something that will possibly blow your mind. It certainly did me if you haven't realized this yet. What is a receive address then? You know, this is the address that's in your wallet. It starts with XCH, blah, 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 blah. And you can generate several of these if you need to, if you'd like, and send them out to different people. What is it? Well, actually, it's a puzzle hash. It's just simply a specially encoded puzzle hash, but it is a puzzle hash. So when you send out your address to somebody, you're actually sending them a hash of some special code that only you know that's private. So some private code that only you know about. And you're saying, here, lock up this coin with this puzzle hash and only I will be able to unlock that coin later with the exact code behind that puzzle hash. And we'll talk more about this in a minute, but think of it almost like, think of your receive address now as a combination lock. Instead of, when I first started getting into Chia and learning about sending funds to different people, I imagined a receive address as much like an email address or even a home address. It's something that you send something to. But really, it's not that at all, even though that's a good analogy. Behind the scenes, as developers, we need to understand that a receive address is actually just a puzzle hash of some special private code that I've created that will lock up that coin just for me so that only I can unlock it. And again, think of it like a combination. So imagine a combination lock, an unlocked combination lock. Imagine you sent your friend an unlocked combination lock. Only you know the combination. And you said, here, friend, lock up this box with that lock, and then send that back to me. And so you would know that once they lock that lock, once they lock your lock, they can't unlock it because they don't know the code. But they were able to lock it in the first place, at least. So it's kind of a one-way street, right? Well, this is very similar. When you give out your receive address, you're actually giving out, in this analogy, a combination lock, an unlocked lock. And you're saying, here, lock up this coin, lock up a coin with this unlocked lock, and that way later on I'll be able to go unlock it with my secret key and spend it. And that's how somebody, quote unquote, sends you a coin. So this is a very important concept to understand because this is the basis of the rest of your understanding around puzzle hashes, I think. A receive address is really just a puzzle hash. And how does this actually work? So your wallet generates a receive address, right? So your wallet is going to generate a new receive address. It needs to go look up the standard transaction code in Chia, so it gets all of that code. And then it's going to insert your secret. This would be your signature of some sort. And now it's got a nice block of code. And now it's going to hash that unique block of code to get a hash. Then it's going to encode that hash as a receive address. And now all someone has to do to send you a coin is make a new coin with that address on it, with that hash, that puzzle hash. And they now know that since you are the only one that has that original code, that only you will be able to unlock it and send it to someone else or spend it from there. Okay, so if that all doesn't make sense, just wait. There's even a better analogy later, I think. And you might have to go back and forth a few times and watch these parts again, but don't worry, you'll get it. I think it will click, and this is a very big thing in your journey to understand Chia. Moving on, now that we've defined some terms. So everything in Chia, as we've seen, as we've talked about, is a coin. Behind the scenes, it's a simple, everything is a coin, whether it's an NFT or a DID or any of the fancy new features that we've heard about coming up, or if it's just the regular mojos. Everything is actually, at its base, at least a coin, a one mojo coin at the very least. And remember, one mojo is 1 trillion, one XCH is 1 trillion mojos. So the blockchain itself doesn't actually know about XCH. When we say 1 XCH, the blockchain doesn't understand that. The blockchain sees, 1 trillion mojos, actually. So the smallest transaction is a single mojo on the chain. And there's really no such thing as XCH. That's really just a big number of mojos. But what actually makes up a coin? What, if you think about properties or fields, if you're thinking about in database terms as a developer, what is a coin in the blockchain? Well, it's actually 4 fields or properties. There's a few more, but we are not going to talk about those right now. We will reveal those later. For now, just think about these simple 4 fields. So first of all, we have a puzzle hash. This is the hash of the puzzle code that will unlock this coin. Remember, that's unique, that only the owner knows. We have the parent ID. Where did this coin come from? Obviously, that will be the ID of the parent coin that was spent to create this coin. And then how much is this coin, obviously? Now, if you add up all these three things, you end up with the ID. So we know, what are these values actually? Let's think about that real quick. Well, we know a puzzle hash, we know that's a hash. So that's going to be a hexadecimal looking character, kind of like this, like if we use our famous hexadecimal example here of dead beef. We also know, by the way, that the ID is a hash of all three of these things. So we know the ID is going to look like a hash too. Let's say dead FOOF00D. Okay. We also know that the parent ID is a coin ID, which we now know is a hash. So we can also say that the parent ID is a hash. So that really only leaves amount. Let's make it 1 mojo in this case. So you can see that a coin is really just made up of these three fields, 2 of which are simple hashes, and 1 of which is a simple integer field that's just 1 mojo or whatever, however many mojos this coin represents. And then those 3 together are added together and hashed to equal the ID of this coin, which will be used when we create children coins from this coin, as we spend it, when we spend it. Okay? So relatively simple from that perspective. It is kind of mind-bending to think how all this relates to each other and works together through the chain, but if you just think of it in these terms, you've got 3 fields that create 1 field, and that's it. And they're very simple values. That's kind of the beauty of the simplicity of the system. Now, what can you do with a coin? You really can only spend it. That's it. If you are the owner of a coin, in other words, you know the puzzle behind the puzzle hash for that coin, the only thing you can do is spend it. But you have to know how. And what does that mean? You have to know the original code that matches the puzzle hash that's been posted on that coin on the blockchain. That's the only way you can actually spend that coin. That's enforced by all of your peers. And how do they know that? Well, let's actually talk about what you're going to need to spend your coin. If you want to spend a coin that you own, of course you're going to need to know the coin ID itself, which is those 3 fields pushed together, of course. You're also going to need the original puzzle code that was used to create the puzzle hash on that coin. And this is going to contain this is probably going to be the standard the standard Chia transaction plus your unique bit of signature that was curried in. And then you're going to need a solution. Now, what's the solution? Well, if you think about the original code that was used to make the puzzle hash for this coin, it couldn't possibly have known where you want to send this coin in the future or where you want to create in the future. So when you spend this coin, you need to know the original puzzle code, but you also need to pass that puzzle code some parameters. So again, solution to the puzzle is a nice mnemonic to remember later once you understand this. But for now, just imagine that the solution is parameters passed into that puzzle code that you know, that only you know. And those parameters are going to be things like the receive address. Where do you want to send this coin? It's going to be somebody else's puzzle hash, right? That only they know. So again, it's like you're putting their combination lock on your coin now. And that's how you spend it. You move that coin along to somebody else's ownership. And of course, you're going to need to know the amount of the coins that you want to create. And this is important because you can actually create multiple coins with the same spend, right? So for example, let's say that you have a coin worth 3 mojos and you want to send 2 mojos to your friend and you want to send 1 mojo to another friend. So you could easily do that. You could spend your 3 mojo coin and create 2 new coins, one with 2 mojos and one with 1 mojo, each with their own puzzle hash or receive address, so to speak, so that they each go to the correct owner. Or more appropriately, each owner can now only the owners can unlock those coins to spend them themselves when they want to. Okay? So that's what you need to spend a coin. Now, during that spend, your puzzle code can create new and interesting coins. And these could just be the standard coin, of course. The standard coin goes to somebody else. And when I say create different types of coins, I really just mean you don't even really know it. You're just putting a new puzzle hash on a new coin. You spent yours, you unlocked yours, and now you're going to create a new one with a new puzzle hash of some sort. That new puzzle hash could even be your own puzzle hash again, if you just want to send it to yourself for some reason. As change, maybe. That puzzle hash could be your friend's receive address. That puzzle hash could be any other sort of interesting coin logic that may be created in the future. So, but there is a bit of some restrictions. Let's zoom in on the fine print here. So, when you are spending your coin and creating some new coins, there's some restrictions. New coins may only be created during a spend. So that's obvious, right? You can't just create coins out of thin air. So if you're creating a coin, that means you're spending another coin. The total of new coins must be less than or equal to the amount of the spent coins. That makes sense, right? You can't say, let's say that you want to spend a 3 mojo coin and you want to send 2 mojos to one person and 2 mojos to another. Well, obviously, you've only got 3 mojos, but you're trying to send 4. So that's not going to work. That's going to be rejected by everybody. You're just trying to create money out of thin air. Now, what about the other way? Any leftover value will be awarded to the farmer as a fee. Oh, interesting. No paybacks, no opposite days. It's good that they mentioned that. That's the first thing I would try is to try this on opposite days. So I'm glad that they added that restriction. But let's use this example again. So let's say it's the other way. Let's say that you have a 3 mojo coin and you send 2 mojos to your friend and you just forget about the other one. Well, you can do that. And what that really means is you're leaving the other one as a tip to the farmer. So there, the farmer, whoever farms that block, as we talked about in the last episode, is going to be able to take that extra mojo floating around as a fee and give it to themselves as a coin. So that's how that works. That's how fees work. All right. So to recap quickly, you can spend a coin and then you can create a new coin. But of course, these are the restrictions when doing that. And of course, you can only spend a coin if you know the original puzzle code that was used to create that coin in the first place, the puzzle with the puzzle hash. Now, once a coin is spent, it's gone, right? Well, I mean, kind of. Actually, it's not gone. Nothing's ever gone from the blockchain. It's always there. But it's marked as spent. And by this, I mean it's got a few extra properties, which are everyone can now see how it was spent. So when you spend a coin, it's your responsibility to reveal to everyone, as they call it, how you actually solved this puzzle. And so you actually pass in, when you spend a coin, you are going to actually reveal the original unique puzzle code, not just the hash, the actual unique puzzle code now. You're going to put that on the spent coin. And as well, along with the solution. Remember, the solution are just those parameters that were passed in. So you're going to put the code and the parameters on that spent coin so that everybody can see and verify that that equals the puzzle hash of that spent coin. So obviously you are the owner because only you should have known how to spend it. So again, that's the puzzle reveal and the puzzle solution. I'm sorry, the puzzle reveal and the solution reveal. So the solution, both of these would be tracked on the blockchain as well. So let's recap. I've thought of I think even a better analogy than a combination lock, and I think this will hopefully make sense. If we think about the blockchain itself as almost a locker room or a locker wall, you may have seen these electronic walls at maybe some sort of outdoor fair or some sort of event where you have to store your belongings and you're able to put in a code and lock up your backpack for a certain amount of time and then you can come back and get it later. Something similar to that. So let's imagine the blockchain like this locker wall. And we really only have 3 different states, so to speak, of lockers. We have the future blockchain. These are vacant lockers that anybody can walk up to and use. These are kind of open blocks, so to speak. You've got your unspent coins. These are coins that are right now tied up with existing puzzle codes and puzzle hashes. And these are live coins, so to speak. And then you've also got spent coins. You've got the old coins that were spent, and you've got the actual puzzle code and the solutions available to see exactly how and where they were spent. Okay, so if you can kind of imagine this as moving from, we're going to start at the bottom here with the future blockchain. So let's imagine you want to send a mojo to your friend. Well, your mojo is, first of all, it's going to be locked up somewhere, right? It's going to be locked up in one of these lockers. And if we zoom in here, we see the enter pin. So you're going to have to know the puzzle code, so to speak. That's the pin here. Right now, we just have the puzzle hash out on the chain. So you're going to have to know the secret puzzle code to even open your own locker that has the mojo you want to send. So you do that, you put in your pin, that this locker opens up, and now you're able to take that one mojo and put it in another locker, and a vacant locker. And if you look at this, you see enter address. Now here's where you would put the receiving address. And remember, the receiving address is just a puzzle hash. So you are effectively you are spending your coin by taking it out of your locker, and you're putting that coin in a new locker that's locked up with a new address that only that person that knows that puzzle code behind that address can unlock, right? The other thing you're going to do on this old locker is we're going to turn it into one of these red lockers. So now that locker is going to say used on it, and you're going to actually post right on the front, here's the real puzzle code I used to unlock this locker, and here's the solution parameters I used. And by the way, these solution parameters point to this new address, this new puzzle hash that I used, that I sent this coin to, so to speak. Okay, so that's the idea. There's really only two states, if you think about it, to a coin: spent and unspent. And then, of course, this third kind of future state of just unspent or open blocks in the blockchain, where you would lock up things for other people. So this is the kind of the analogy, and I hope that makes sense. You know, it is kind of a journey learning this stuff, and these analogies aren't perfect by any means, but the hope here is that you can use these analogies and go from there and learn in the real tutorials and the real videos, and have at least a basic kind of mind mapping of what these terms mean and how they're used. I definitely still encourage you to go look at the real documentation, of course, the real tutorials. And now that you kind of understand at a very, very high level what's going on, I think they're going to make a lot more sense to you. They certainly do for me now that I've finally understood some of these basic concepts. So anyway, again, this was Josh Painter. I really hope you enjoy these videos. This was the third episode. You can go back and look on my YouTube channel and look at some of the other videos. The first and second one are fun as well. You can find me on Twitter at Endertown, and you can look up my personal Chia cat token project at CatMosCoin. Anyway, as always, thanks for stopping by. I hope you learned something. I certainly did, as always. And thanks again. Talk to you later.